All right, question number 1. Describe the shape, center, and spread of the sampling distribution of the sample proportion p-hat who own Harleys. Well, first of all, you need to have the mean and the standard deviation. Well, the mean is 0.14 because this says 14% of all motorcycles, so therefore that is your p-value. Okay, that's your p-value, which is also your mean. You need to find the standard deviation, and you do that by the square root of 0.14 times 0.86 divided by 600. When you take the square root of that, you get 0.0142. All right, describe the shape. Well, it's approximately normal. And then you come over here and you build your graph. All right, 0.14 in the middle, then you add 0.0142, add 0.0142, and so on, and then you subtract 0.0142. That's how you do number 1. Number 2, how likely is your sample to contain 18.2%? Well, 18.2% would be about right there on your graph. All right, so you want a z-score. So z is equal to 0.182 minus 0.14 over 0.0142, which gives you a z-score of 2.96. Now, what I'm noticing on some of your papers is that you're not putting the z equals. You're just putting this right here, and you really don't know what this means. You got to then look at your table A, so 2.96. So here's 2.9. And you got to come all the way over to 6. 0, 1, 2, 3, 4, 5, 6. So 0.9985. All right? What happens is that gives the area to the left. That gives this area right here. So we want this area right here to the right because it says more than. All right? So we subtract this area from 1 and we get 0.0015. And the question is, how likely is your sample to contain this? You answer the question, the probability of more than 18.2% would be 0.0015, so it's not very likely that it would happen. Okay? Now, on C, how likely is your sample to contain less than 12%? Again, same format. Find a z-score of negative 1.41. When you look at it on your table A, you get an area of 0.0793. And what that would mean is when you draw your graph, it's going to be from here to the left. And 0.0793, if we converted that to a percentage, 7.93%, that wouldn't happen very often. So the statement I would like to see is it would be somewhat unlikely, but not surprising, because it still has a chance of happening. Whereas the 0.0015 before would very rarely happen, if at all. All right, now number 2. The question says, how much larger is the quick method margin of error? So in this one, what you had to do is you had to create a confidence interval using the quick method and using the method from the book. So the quick method, we had to find 1 over the square root of n, which is 0.0408. That's p-hat plus or minus the margin of error. So this is your margin of error. So you get 0.1133 plus or minus 1 over the square root of n. So you're just going to substitute 0.0408 right here, and you get a confidence interval of 0.0725 to 0.1541. Now, doing it the long way from the textbook, again, 0.1133 is our p-hat that we got previously. Plus or minus, since it's a 95% confidence interval, it's 1.96. P-hat, 1 minus p-hat over 600. Take the square root of that. So I just simply put that in the calculator, and I got 0.0879 to 0.1387. And to answer the question, how much larger is the quick method margin of error? Well, quick method minus the formula here, minus 0.0254, and then I get 0.0154, which is about 1.5%. All right, over on the back on number 3, now it says, to what population is it reasonable to generalize the result of the survey? And justify your answer. We are talking about social scientists asking 127 undergraduate students from those who take a psychology and communications course and about prayer, and found that 107 prayed at least a few times a year. So assuming the sample is chosen randomly, it would be reasonable to generalize the result of this survey to undergraduate students taking courses in psychology and communications, since this is where the sample was drawn. Okay? Now, the next question is calculate and interpret a 99% confidence interval. Well, I need my information of p hat plus or minus z star times the square root of this right here. Now, my p hat is 107 over 127, which is 0.8425. What I'm going to do is I'm going to put this in the calculator just like this with my fractions to eliminate round-off error. All right, and what it's going to look like is this. So if I want to calculate it and eliminate round-off error, it's going to look like this. So first of all, I have a fraction, 107 over 127. I'm going to do the minus first, 2.58, shift, square root, create a fraction there. Now within that fraction, I'm going to put a couple sets of parentheses. Now within that fraction, I'm going to put, or in that parenthesis, I'm going to put a fraction, and that's going to be my 107 over 127. And then within this parentheses, it's 1 minus, again, another fraction of 107 over 127. All over 127. When I hit enter, that is the lower end of my confidence interval, so 0.7591. I go back up here and I change the subtraction to a plus, to an addition, and that gives me the upper end, so 0.9259. And that is what I have here. My confidence statement is we are 99% confident that the true proportion of undergraduate students taking psychology and communications, or communication, pray at least a few times a year, is between 0.7591 and 0.9259. All right, question number 4. Let me minimize this a little bit. P hat is 0.3534. The confidence interval is 0.3226, 0.3842. And what is the margin of error for your confidence interval? Well, this gives you your margin of error, which is 0.0308.